Hi everyone, it's Nono here, and this is a quick overview on how we can vectorize our drawings in really high quality with virtual sketching. This is a recently published paper that we're going to see today. And before we get started, I want to show you some of the results that I've obtained with my own sketches, my own drawings. What you can see here, this is Muten Roy from Dragon Ball. This is something that already exists on the sample of the paper. And what you see on the bottom is a raster image of what I imagine was a vector drawing or a high resolution scan. And on the top, you can see all of the strokes that have been converted in the process of running this algorithm. On the middle, you have a sketch that I did. And on the top, you have vectorization of that sketch with every single individual stroke in different colors. I think the color mentions just different sets of strokes and moments in the drawing. On the right, you have another illustration that we use with the same vectorization model. And when you make a vectorization, the model gives you these diagrams in which you can see the order in which they were sketched and also the logic of the path. Like on the right, you have a continuous path for how it followed the drawing. You get a sense of where it started or where it finished. And for everything else, it's just if you remove the parts of the drawing, like you can see in here, right? If you remove the parts of the drawing that are continuous and make the drawing be weird, like if you didn't ever put your pen up, you'll see something like this. So this is actually a sketch I did back in 2016 or 17 of Panagiotis Michalatos. And this is the vectorization. I think this is super cool. It's super easy to get it done. I think this is super impressive how well it works, and I'm definitely going to be using it more on the live stream and on my own projects. Again, this is, I think I can show again, we showed this before, but the neural network actually, what it does is that it has this sliding window that it zooms in and out to look for strokes, and it tries to find the paths and vectorize them and then paste them back on the overall drawing and make continuous strokes. To name the paper, this is called General Virtual Sketching Framework for Vector Line Art. Was presented at SIGGRAPH 2021. I will thank Rob Beal again for sending this to the Discord servers on the community. We have a channel where we can share papers, also the machine learning channel. This was a paper as a result of work by Mo, Haoran, Simo Serra, Edgar, Angao, Chenyi and Zhu, Chanki and Wang, and Romei. Thanks a lot for putting this code out in the open. And without further ado, let's dive into the code and actually get to use this machine learning algorithm. First, let's open back that repo that we had before. This was the General Virtual Sketching, right? This is their publication. This is the example that I grabbed. And there are more. So if we go to the paper, we'll see the neural network architecture, which they have here as well. And I don't fully understand because I haven't read the paper, and some of these things actually get out of my understanding of machine learning. But what seems to be happening is that there is a step in which we have this sliding window. We have a sliding window that moves and tries to plot different points. And it tries to generate the strokes. It tries to vectorize. And we have another model that renders and then it pastes back on the window. What I don't know is if they stitch those together, right? Because as you can see here, there are different parts that are being curved by that sliding window. And then they get pasted back in place. It seems like it's trying to connect different points together at the end to make a cleaner path, sequential strokes in the canvas. And there is a CNN encoder, so we encode the drawing, or the presentation is on YouTube. I watched this video, which I recommend you see. This is what we saw before. These are other examples. So you can see this one also works pretty well. This is surprising because this is actually a hand sketch with a pencil. And this too, which is trying to simplify a face or make a sketch of a face, which is pretty cool. And here are more results. Turn volume off. I don't know if this has audio. But yeah, I saw this one. So these are clean drawings, but then later I think they show, these are raster images of drawings that should be easy to vectorize. And these ones are really cool that this works. Okay, and these are just more examples of the same. Pre-computed results, presentations. Let's open the paper really quickly before we go to the code. And let's see. Would be great to touch base with these people. So giving clean line drawings, rough sketches of photographs of arbitrary resolution as input, our framework generates the corresponding vector line drawings directly. The framework models a virtual pencil random by the mind window, red boxes which moves while drawing the strokes. It learns to move around by scaling the window and sliding to an undrawn area for restarting the drawing. Modern examples are in directory in a blue arrow. With our proposed stroke regularization mechanism, framework is able to enlarge the window and draw long strokes for simplicity. I guess I'll have to review the paper on my own. Okay. In our framework are represented in relative manner. Continuous stroke, which is similar to the 3-stroke format in Sketch. We are familiar with this one. We've covered it on the live stream and other videos. If you want to learn more, so I think by putting here Sketch-RNN, no, YouTube, yes, this video, which I'm going to put also on the links. Right, so I have this video on the channel I did a while ago for 2018. It does talk about the encoding of the strokes in this way. So this is for Sketch-RNN. And here we even have an example of the encoded strokes and examples of things generated with pix-to-pix. So this is a one hop vector. This is X and Y. So this is each step is like the delta, like how much you moved from the previous point. And then we have this one hot vector on the right. If it's 1, 0, 0 or 0, 1, 0 or 0, 0, 1, means 3 different things. The first one is that the pen is touching the paper. A line will be drawn connected to the next point. And 0, 0, 1, 0 is that the pen will be lifted after the current point. And then if it's 0, 0, 1 means that the drawing has ended and no more points are going to be drawn and the drawing is finished. I'm going to move now into actual code. So we go to the repo here on GitHub. Uses TensorFlow. Why are they still using TensorFlow 1.12, 1.15? They might have been developing this for a long time, because using this is like, now we're up to TensorFlow 2.4 point something or 2.5 or 2.6. I don't know how many versions they release in the summer. Maybe there's an opportunity here to port this model to TensorFlow 2 if it's not too hard. Download the models here. Among works that do not require training vector data, learning to paint is the approach closest to a framework, albeit with some noticeable differences. So the models are here. So these are the data sets. Quick draw. That's what I was looking for. Yeah. So quick draw all of our results. I'm going to download everything from here. And okay, so we have then place them in this file structure. Output, snapshot, blah, blah, blah. Choose the image in the sample inputs directory and run one of the following commands for each task. The result will be under output sampling. Python 3, Mutant. Okay, do we have a requirements.txt file? They don't have it, but I guess we can get it from here. So it works in Colab. It's installing the TensorFlow that we need. Let's see a version. All right, so we have it here. So let me see. So you said that testing with train weights. Yeah, so test vectorization here still requires TensorFlow, right? So that's what we're gonna do. But we're not gonna train right now, but we're gonna do it in Colab. So here we do have TensorFlow 15, which is what we need, so we can import it. And what we're going to do is that we're going to clone this repo here. So git clone that, and then we'll do... Okay, so that worked there. And now we do need to download all the files. Okay, so I've downloaded the pre-trained models, and I'll put here that link as well. Well, that link is on the repo, so we don't really need to put it there. So we'll just see the links file. So okay. So you have the drive, pre-trained models used for testing, clean line drawings. All right, this one we're gonna see it's a file. These are the train weights. This is the model config. We probably need to upload this thing to Colab. So it says place them in this file structure. That's not it. Testing with download the models here. Pre-trained clean drawings for vectorization. So that's pre-trained clean drawings, and we have the zip file here. Place them in output snapshot pre-trained. Okay, output snapshot. So we're gonna go here and say, okay, make a dir. It's gonna be outputs. Make a dir. It's gonna be outputs snapshot, and then make a dir. There's gonna be outputs snapshot. Okay, let's see if that gets created. Oh, but we need to do it in virtual sketching. So we put it here and then we run it there. Okay, so we get outputs, snapshot, pre-trained clean drawings. Okay, we just need to, these are really small, so we're gonna upload that directly. That's already there. And now we need this one. We are gonna try to do that. Otherwise, we'll have to download them with another request, and that's uploading there. All right, let's hope that that's not too slow. And now we're gonna get back here. We do need to install the dependencies, so we don't have Pillow, OpenCV, site. So let's try to build a command for that. Command call for that. We'll just do this, and again, just put this, and that should be pip3 install. All right, let's try that. So this is gonna take a bit to upload. Let's see, the models are here. So get link. Okay, bear with me. We're almost there. Let's see if this works or not. I'm just trying to look for a code to download files before I. So we'll do wget o. I don't know. O. We'll do it virtual sketching outputs snapshot pre-trained clean drawings.zip. So I'm gonna just put it on Dropbox. All right. So we have a Dropbox link now for this file. So I have it on my other window. Get that link, and you just need to put that here. Let's try again. Okay, so that's downloading now, and supposedly this is going to be able to unzip it. Conflating. All right, so we did that, which I guess is okay. Just move that one there. It seems like the model is properly uploaded, and I'm not sure if we have the right dependencies, but if I do this and then I run that and then I do this. Okay, we're on the repo. So it seems like we're able now to run the command, and we'll see. And do we have Muten? So sample inputs, we have clean line drawings, and then there we have Muten PNG. Let's try this out. Python pre-trained rough sketches. That's not the one that we're using, right? So it's the clean line drawings. Probably is this one, test vectorization. Well, it's good that we're getting that failure because that's easy to fix. Okay, let's see. Fingers crossed. And I don't have the chat, so I don't know. Oh, that seems like something's working. Anyone there? Okay, we have another no such file led to sample input. Okay, the model is hard-coded as much as they could. Yes. Now I'm gonna go to my sketch. I'm gonna go here and I'm gonna give it an example drawing. Let's try with this one. Let me switch on the screen. I'm gonna get to download the Muten image just to see how it is, the resolution and things like that, to see if we need a specific image. So we have here clean line drawings, Muten. So this is big. I think they do have different resolutions, so we don't really, I don't think we need to do anything to it. This is a PNG, that might be, okay, so let's convert the image that we have on our desktop. So this is this one, so let's convert it to PNG. All right, sketch, and we're going to place that. Okay, so this is doing compute and stuff, and I'm not sure, it seems like this has saved already. So the sampling order, so the prediction is here. Cool. So this works was pretty easy to make it work in some way, and nice. And this was the input, right? So you see that the output is a lot cleaner than the input, and is exactly the same, which is really cool. There's some noise and stuff. Sequential data, order compare, and I don't know where the vector data is output to. I'm gonna put here clean line drawings. We're gonna put no sketch, and we're gonna put in clean line drawings. So we're gonna change this. We're gonna change this to no sketch, and we're gonna run it. And this takes a bit, as we saw before, probably also depending on the resolution. And it's running, so it's processing non-sketch, image size 200/500. Yeah, I don't know, maybe this image is bigger than it needs to be. Let's make it a bit smaller and crop it. All right, so I made the same image now 1000 pixels instead of 2500. I'm gonna put it here, and we can run the same thing below. We'll run later with 1000. Takes long. Should try with some of the other models as well. Yeah, I'm curious about what happens if I give it a sketch that is not super polished. Let's try with this one. So we have here pan, and we're gonna put pan here, and we'll do this with pan when this one finishes. And this is clean line drawings, Muten, no sketch input. The input we already know what it is. It's here. It's a bit big. Yeah, it's probably too big for compared to the size of the others. Saving results, sequential data, non-sketch, prediction. Okay, I don't know what this one is. Sequential data, MPC format. Is it NumPy? I don't know if this will fail, whatever. Okay, so this is still saving results, round lines. So we've exported a sketch that is way too big, so that this probably now is executing, takes shorter. And I'm not sure what's happened, but this doesn't seem like it's saved. This one might be faster. Snapshots. I see on the repo, okay. So here, there. The conversion result. Okay, so I guess this will work right out of the bat. So it's gonna take a bit. I'm gonna share this to make sure everyone has access. Change to anyone with the link, copy link. That's gonna go also to the channel. And done, so that I'm gonna put here. Hopefully you can enter already, it will be empty. And I'm gonna just put these things here. Okay, we download the model. We then, yeah, for me I had this thing to unzip. It's better if we put this here. So we get an MPC file object. Okay, so let's try that. Let's just print sec data files. Awesome. So we have all of these files there. So we'll get here strokes data. So this is the stroke data. So we actually get the data of the, okay, so inspect vector vector data. And to avoid this not working for you, I'll put this here, Muten, and then we'll print this, and we'll print this. Cool. Great. So I'm gonna save, and yeah, lastly, we're just gonna see the results just to see if this makes any sense at all. We have the sketch for the small sketch of mine. So we got the thing on the right, so it's pretty neat, pretty accurate. So it's pretty crazy because this means that this is a vectorized version of this. This is just hand sketched, and this is now scalable to any size. This is, guys, this is really good. This is really good. We can try this further. I don't need to save it. I want to save these sketches. So that's super cool. Let's see for pants prediction. Nice. Okay, so this is also really good. It's also a really good vectorization of the sketch. I'm pretty impressed. And these are the paths. Okay, so I don't know how it does it, but it's really good. And I'm just gonna save these images as a memory of today's live stream. And what's the difference with this? Okay, so this is the high resolution prediction. What you can see here, this is Muten Roy from Dragon Ball. This is something that already exists on the sample of the paper. And what you see on the bottom is a raster image of what I imagine was a vector drawing or a high resolution scan. And on the top, you can see all of the strokes that have been converted in the process of running this algorithm. On the middle, you have a sketch that I did. And on the top, you have vectorization of that sketch with every single individual stroke in different colors. I think the color mentions just different sets of strokes and moments in the drawing. On the right, you have another illustration that we use with the same vectorization model. And when you make a vectorization, the model gives you these diagrams in which you can see the order in which they were sketched and also the logic of the path. Like on the right, you have a continuous path for how it followed the drawing. You can see, get a sense of where it started or where it finished. And for everything else, it's just like if you remove the parts of the drawing, like you can see in here, right? If you remove the parts of the drawing that are continuous and make the drawing be weird, like if you didn't ever put your pen up, you'll see something like this. Okay, thanks so much, guys. I'll see you next time, and thank you, really. Bye.